Hi everyone, we're going to do the Principle of Mathematical Induction Part 3. These are harder than the ones we did earlier in Part 1 and Part 2, and I'm going to do 4 of these. So here's the first one, and I assume you already know that we have to do Condition 1 and Condition 2. So the first thing we're going to do is check for n equals 1, and I'm going to take this and plug in 1. When I plug in 1, I get a 1 over 1 plus 1 is 1/2. That should equal my first term, and it does. So condition 1 holds. So we're going to check and see if it holds for some k for condition 2. So basically I'm going to copy down the same thing, but substitute in k for n. Okay, and then we're going to check for k plus 1. We know it holds for 1, but we're going to check for k plus 1. So basically we're looking for the next term. And what I'm going to do is copy this whole thing down. Then I'm going to add the next term. So I'm going to write this as 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus dot 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 plus 1 over k times k plus 1. Now that I've added this term, I'm going to add the next one. So basically the next term would be 1 over, and we're adding k plus 1 to this k, and this one's going to be k plus 1, which is k plus 2. And this should equal k plus 1 over k plus 2. So just keeping this in mind, this is what our end should look like. So now this whole thing here equals k over k plus 1. That's why we had to copy it down again. And now, because of this line here, all this equals k plus 1. Now I'm going to add my next term. So my next term would be k plus 1 times k plus 2. Now, my common denominator is k plus 1 plus k plus 2. So what I'm going to do is multiply everything through by my common denominator. And I'm going to do that on the next page. So we're going to get, once we do that, we're going to get k. Let me go back. So basically, we're going to have to multiply this k by k plus 2. So we're going to get k times k plus 2 all over k plus 1 times k plus 2. Then I have to add my 1. So that was my common denominator. And I'm going to go back. Basically what I did is I just multiplied everything through by my common denominator, which was k plus 1 times k plus 2. When you multiply this first one, you're going to get k plus 2, and you have to multiply it by the k. And this would cancel, but you keep your common denominator. So once you have that, we're going to clean the numerator up, and we get k squared plus 2k plus 1 over k plus 1 times k plus 2. Now I'm going to factor out the numerator, factor it, k plus 1 times k plus 1 over k plus 1 times k plus 2. When you cancel it out, we get k plus 1 over k plus 2, and that equals what we were looking for here in this blue thing here. K plus 1 over k plus 2. Okay? The next one we have is something similar. It's going to be 1 over 1 times 3 plus 1 plus, let me erase this. I'm trying to copy my writing down. Plus 1 over 3 times 5. What do you think the next one's going to be? Plus 1 over 5 times 7. Plus dot, dot, dot. Plus 1 over 2n minus 1 times 2n plus 1. And that is going to equal n over 2n plus 1. Okay, now we just check for condition 1. We're going to check for n equals 1. And when we do that, it should equal 1/3. So I'm going to plug in 1 over 2 times 1. And this, we're plugging it in here. Plus 1. And that gives us 1/3. So it equals our first term here. Now I'm going to check for condition 2. Since that holds, I'm going to write everything with k. 3 times 5 plus 1 over 5 times 7 plus dot, dot, dot plus 1 over 2k minus 1 times 2k plus 1. And all that should equal k plus 1, no, just k over 2k plus 1. Now I'm going to write it again, and hopefully I have room, and I'm going to add another term here. Right in here, I'm going to be adding another term after this one. So I'm probably going to skip this one here to save some room. So we have 1 over 1 times 3 plus 1 over 3 times 5 plus dot, dot, dot plus 1 over 2k minus 1 times 2k plus 1. Okay, so I just copied that down. Now I'm adding my new term here, which is going to be 1 over 2k plus 1 times 2k plus 3. Okay, and basically what you're doing is you're taking, like, say, for example, this one, and you put in k plus 1, substitute that, and you get 2k plus 2 minus 1. And that's what gives you that. And do it again for this one here. Or you can just see it's going up by 2's. We're going up by 2's here, right? This is 3. We're going up by 2's. Going up by 2's here. So I just added 2 to the 1. And I added 2 to the 1 here, and I got 3. Now this side is supposed to equal k plus 1 over 2k plus 3. I just added 2 here. And I kept my slope. That's kind of your slope. Okay, so this is our goal. We want our equation to look like that. Now, this whole thing equals k over 2k plus 1. That's why we copied it down again, because this whole thing here equals that. Then you add your part that you already added, which is 1 over 2k plus 1 times 2k plus 3. All right? Now what I'm going to do here is basically multiply my k here by 2k plus 3 to have the common denominator. And this is going to be my common denominator. So I'm going to write that down. So that's going to be k times 2k plus 3 plus whatever I had, which was 1, over 2k plus 1 times 2k plus 3. That's just getting the common denominator. Now clean this up. You have 2k squared plus 3k plus 1 over 2k plus 1 times 2k plus 3. Now we're going to factor, and we're going to get 2k plus 1 times k plus 1, I believe. I'm going to check that in a minute. So we get 2k plus 1 for our denominator, 2k plus 3. Now let me just check did I factor that right. That's 2k and 1k. So, well, that's 2k and 1k. So we got it. Now these cancel, and we're left with k plus 1 over 2k plus 3. Now I'm going to check and see, is that what we wanted? Yes. So my little thing, this equals k plus 1 over 2k plus 3. Okay, let's do one more. The next one is, we have 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared equals 1/6 n times n plus 1 times 2n plus 1. Now I have to check for condition 1. When I plug in 1 in here, it should equal 1. So let me check for n equals 1. Get 1/6 times 1 times 1 plus 1 times 2 times 1 plus 1. This is 1/6 times 6. That equals 1. So condition 1 holds. It should always hold. Now, unless you wrote something down wrong. So we got to check for 2, and we're just going to write everything down, but everywhere there's an n, we're going to put a k. All right. Now, we want to see if it holds for the next term, or what I say, k plus 1. So what I'm going to do is rewrite this, and this is going to be 1 squared plus 2 squared plus 3 squared plus k squared. So I just copied this whole thing down. Now my next term is going to be k plus 1 squared. And this is supposed to equal 1 over 6 times k. We're just adding 1 to everything. So this is 1. So when we add 1, you get 2. In this case, this is going to be 2k plus 2. All right. So this is what our goal is for it to look like. All right. Now, when you do that, you're going to get this whole thing equals 1/6 times k plus 1 times 2k plus 1. And I'm going to go ahead and factor this out. This is k squared plus 2k plus 1. Now, when I clean this up, I'm going to get, okay, so what I'm going to do is factor out a k plus 1. So I want to rewrite this as k plus 1 times k plus 1. And I'm going to factor out a k plus 1 and then rewrite this as 1/6 k times 2k plus 1 plus k plus 1. All right. And I'm going to take care of this, and I'm going to get k plus 1 and simplify this, which is going to give me 1/3 k squared plus 1/6 k plus k plus 1. Now, I'm going to further clean this up, and I'm going to get k plus 1 equals 1/3 k squared plus 7 over 6k plus 1. Okay, I'm going to factor out a 1/6. When I factor out a 1/6, I'm going to get 1/6. Sorry about that. 1/6 k plus 1. And this is going to turn into a 2 because I'm factoring out a 6. So if I say 1/6 times 2, that's 1/3. So that's why I factored out that. And then I'm going to get plus 7k plus 6. Because 1/6 of 6 is 1. All right? And then when you factor, you get 1/6 times k plus 1 times, and I'm going to factor these out, and you're going to get k plus 2 times 2k plus 3. And when you clean that up, you should get our original, which is here, which we have it. So that equals what we want. I can write it again. This just equals what we wanted to begin with. K plus 1 times k plus 2 times 2k plus 3. You can see where this is a little harder. You just need to know a few algebra tricks and you're good to go. Okay, the next set is very similar and it's going to have more algebra tricks.